Just wanted us to, always wanted to start a presentation with that. Okay, we're going to be talking about some conflicts between Docker and systemd. Most of these have been worked out over the last couple of years, but there's the guy that's the head of Docker, or the chief technology officer of Docker, Solomon Hykes, and Leonard's Pottering. Anybody see Leonard's talk this week? So Leonard is the guru of systemd. And both of them are very opinionated, and trying to work with both upstreams has been a challenge. So we're going to talk about what's happened and ways these guys work together. Or as Rodney King said, can't we just all get along? So first we're going to look at, really what we're looking at here is how do you integrate containers of the Docker daemon and the containers that it's executing into the system environment, right? So my goal is to make containers work well with the operating system. And we're going to go through all the different ways we've done that and the problems we've had getting it to where we want it to be. So Docker daemon, first of all, starts via a systemd unit file. So when you boot up a RHEL system, Fedora system, Ubuntu system, anybody, there's a Docker unit file that boots it up and the Docker daemon runs inside of it. And we want the Docker daemon to work well with systemd. So systemd has this thing called SD notify. SD notify is systemd notify, I guess is what the SD stands for. But the idea here is when you have a init system coming up, when the processes, you could basically say, I don't want this program to run until systemd is up. Okay, so what does that mean? So in a traditional sys5 init system, it just meant that the init script had run. But not necessarily, the application probably is not fully ready to receive requests. So if you were launching a MariaDB database or some other tool to come up, you really want that tool to basically say, I'm ready to receive requests now. Right? And that's what SD notify is. So systemd defined a protocol that a process can basically, once it gets to a good state where it's ready to do activity, it can send a signal to systemd and say, I'm ready, at which point systemd will start the other services that are relying on it. That's SD notify. So Docker daemon, actually, we got patches into the Docker daemon that it does SD notify. So basically, if you want to start up, if you have a whole bunch of sys5 init scripts that are run the Docker client, you can make them rely on the Docker daemon starting, and Docker daemon will be fully up before those start. So that was success. Socket activation. So socket activation is another really cool systemd thing in that in traditional Unix systems, you would have all these services up and running, using up memory all the time, even though they might not be doing anything. So socket activation is a on-demand starting of a service. So you can tell systemd that, hey, if someone connects to a socket at var run Docker sock or connects to this network port, port 80, as soon as it connects to port 80, I want you to launch a service and hand that connection to the service. So you could basically have Apache, MariaDB, lots and lots of tools doing socket activation. Docker actually supports socket activation too. So we actually have Docker daemon can do socket activation. It listens on var run Docker socket. So if you had your Docker daemon with those services running, you could actually set up a Docker unit file that when Docker, that when someone connects, if you went with a client and connected to var run socket, the systemd would actually launch the Docker daemon at that point. We don't recommend that. We disable it by default. The reason for that is it breaks auto restart. So if you basically if you configure Docker daemon to automatically start applications when it boots, Docker daemon is not going to start if it has if it has a socket activation, so it won't start until a client connects to it. So you really don't want that. Most people don't want that behavior, but it does support it if you wanted to do it. Note there used to be a bug, but I don't think that's true anymore. So another question that comes up when we look at Docker daemon, so in a lot of ways, Docker daemon wants to be a process manager. Systemd is the process manager. So there's always a conflict between who's in charge of starting the process, starting up the containers. So a lot of times, a question that comes up to me is who owns restart, or who owns start up the service. So you could either have build a systemd unit file, put a Docker run command in it, and that would talk to the Docker daemon and start a service. Or you could create your Docker container, you can tell systemd to automatically start it as soon as you start up, so auto start. So you really have a choice there. I would recommend that you do this right now inside of the Docker daemon. It just simplifies things. So if you just do it in the Docker daemon right now, let Docker maintain the auto starting of the containers. Or you can do Docker run inside of a unifile with auto restart. The problem, prior to Docker 1.11, the reason we used to recommend this is if you restarted the Docker daemon with Docker 1.10 or less, it takes down all your containers. All right, so if you have lots and lots of services running, it takes down the containers. So one of the things you have to worry about is if you were doing a yum update, all of a sudden it brings in a new Docker code. As soon as if the Docker RPM did a restart, all your containers would go away. So after Docker 1.11, and now that Docker 1.11 is out in Docker 1.12, they've separated out the containers from the actual Docker daemon, so it doesn't cause this problem anymore. So you actually have more choice now than you had before who's going to start auto start your applications. Okay, so systemd. So that was systemd working with the Docker daemon. Now we want to look at systemd working with the Docker containers, or the containers that are launched underneath Docker. So we wanted to have SD notify. So again, if you have MariaDB running on a system, you can set up MariaDB to SD notify so that your web services come up when MariaDB is fully up. So what we wanted to have was, if you're running MariaDB inside of a container, it would be really nice if Docker daemon passed down the SD notify to MariaDB. When MariaDB came up, it would do it, right? That would be kind of a nice feature. So we wanted to run in a Docker container. The problem is that Docker is a client-server operation. So when you start containers right now, you actually execute the Docker client. It connects to a service, the Docker daemon, and asks the Docker daemon to start the service. So we actually went through the process of creating a patch that systemd would request SD notify to the Docker client. Then the Docker client would send the SD notify over to the server side, message to the server. The server was sets up to, the server, when it got an SD notify, would set up its client or its container to support SD notify. The server inside of the container gets SD notify, responds. The server sends SD notify message back to the client, and the client sends SD notify to systemd. That's the patch we attempted to get into Docker. Patch is not accepted. Okay, you're going to see a theme here. And I can understand why they didn't want you. It just, because of Docker being built as this client-server operation, it really makes doing things like this very difficult. So if you think about it, if you have a systemd unifile, systemd sort of expects all the processes to be grandchildren of the unifile, or the first service in the unifile. But really, a container process ends up not being a child of the unifile that you define the Docker run it. It's actually a child of the Docker daemon. So it caused problems. So we also looked at socket activation for it, and we didn't even try. Okay, because you can imagine socket activation, you would be basically handing down an open socket, and then you'd want the Docker client to somehow send the open socket over to the daemon. The daemon would then take that open socket, pass it down, and it was just way too complicated to get. So bottom line, SD notify and socket activation do not really work do not work well for Docker containers, running inside with the Docker run command. Another interesting thing that systemd and Docker fight over is who does the cgroup configuration. All right, so systemd has again, you're putting a service into a normal service into a unifile. You can actually do systemd controls to change the cgroup configuration of the unifile. That doesn't work because of the client-server operation. So Docker manages cgroups itself. So if you try to use systemd to system control to change the cgroup configuration of a unifile that's running the Docker client, guess what? You modify the Docker client. You don't really modify what you think you are, which is the container processes. You have no effect on the container processes. That's all managed on the Docker daemon side. So everybody here heard of runC? Okay, nobody? You can raise your hand. Somebody's heard of runC. Okay, so last couple of years there's been an effort to create standards around running containers. And there was a thing called the Open Container Initiative. And one of the first things in the Open Container Initiative was to create a runtime environment for containers. Okay, that was outside of the control of Docker, but basically in a consortium process. And the tool that came out of that was runC. runC, along with a specification, there's a JSON configuration file that tells you how it tells runC how to run a container, and then there's a definition of what the rootfs looks like for running the container. As of Docker 1.11, Docker is now using runC to launch containers. So runC is integral to Docker, but it can be used outside of Docker. So we went back into runC and we looked at how can we get systemd configuration into runC, and runC is not a client-server operation, so runC basically just execs the container as a child of its process. So runC was, as I said, the OCI, or Open Container Initiative, did not use a client-server model. runC containers in UNIFILE files work really well with systemd, okay, because it is, again, it's the grandchild, right? The container ends up being a child of the process that starts it. So SD notify, we got merged, so we got the functionality to do SD notify merged into runC, and we also got socket activation merged into runC. It's a lot simpler. But anyway, so runC now, if you run runC containers out of systemd UNIFILEs, they work well. If you modify cgroup UNIFILEs, it also works. The problem is that runC can also modify systemd, so there can be a conflict between the two. But again, since the processes is inside the same cgroup that launched it, because it's a child of runC, you can actually use systemd controls to modify runC settings. There's a new thing we're working on right now called system containers. You'll probably be seeing, if you're on RHEL systems, you'll probably be seeing it in the next release of our container initiative. And what system containers are using runC in a read-only rootfs for early boot containers. So Docker has a problem. They're trying to figure out how to fix this, but in certain cases you need containers to start before other containers. All right, so you might want to have one container, require another container to be up and running, especially as we move to more of container-only platforms. In our case, we need to get Kubernetes up and running. We need to have etcd running. We need to have flannel running all before Docker daemon is running. So what we're building is basically system containers, which are going to be runC containers that we have building tooling to be able to pull onto say, an atomic host and start them up. And then we're going to use systemd to do our precedence. All right, because systemd does a really good job of making sure that this service runs before others. And also, you can take advantage of things like socket activation. So all this flow of starting services works really well, whereas Docker daemon eventually, I guess, is going to work out some kind of priority ordering. I'm not sure how they're going to do it, and I have a fear that it's going to end up being like a sys5 init system where you have these random numbers that you're choosing for priority. But systemd excels at starting things up. Takes advantage of systemd startup order, and will be in 7.2.6. We just released this week 7.2.5 or 7.3. I'm not sure which one comes. If 7.3 is our next release, or 7.2.6. Probably about 6 weeks from right now, we'll have system containers. Another interesting problem with Docker is where do the log files go? So right now, the Docker daemon has multiple, or had multiple logging agents. So when you run your container, those logs that come out, if you did a Docker logs, you'd be able to see all the stuff that's going on inside of the container. Right now, the default version that comes from Docker goes to a JSON file inside of the container's file system. The problem with that is if you did a Docker remove of the container ID, it actually not only removed the container, it removed the logs. So you don't end up with permanent logs on your system. So we added a patch, and this got merged into it to support journald. So now Red Hat-based Docker daemons come with journald on as a default. So when you do your Docker logs now, it's actually talking to journald. You get some version of structured logging with it, but the main point is if you remove your container, we still have a log. So if you ran a super privileged container that broke out and did evil stuff on the system, there would be still some logging data to figure out what it did. So someone couldn't just log a container, do their evil stuff, and then remove the container. So as of right now in Rawhide, Fedora 24 and 7.3, journal D will be the default log driver for Docker from us. So now we've covered sort of running the Docker daemon and running runC and stuff like that. Now we're looking at the base images and what goes into the base image. So systemd, when we were first working on systemd, first working on base images, we had a problem. Everybody wants minimal image size, right? Everybody has this goal of having a small base image for several reasons. But one of the problems is that the way we package software is that the package software expects that system control is in the base image. So packages required user bin system control for post-install scripts, and that caused systemd to get sucked in. So when we were first doing the base image, systemd was really large, so we wanted to figure out a way that we couldn't have systemd. So I came up with these great ideas. So first I came up with fake systemd. Okay, and all fake systemd was just a little RPM that said, I'm providing system control, so if you installed it, systemd wouldn't come in, but you get fake systemd. Leonard hated it. Okay, so I went to next version. We came out with systemd container. We pulled out fake systemd, and we actually had a systemd that was built with special flags to minimize the amount of requirements of systemd. Because what was happening earlier with systemd, you wouldn't get just systemd, you would get udev, you would get all this other cruft that systemd had requirements on. So we rebuilt systemd container to minimize the amount of requirements needed, so you could install in the base image systemd container, and now you had a smaller base image, and Leonard hated it. And so in version 3, in the 7.2 version, now the base image comes with systemd. The nice thing is that systemd has been updated, so they cleaned up a whole bunch of their crap, the crap requires that they really didn't need. And as we go forward, so this is, as we go forward, Fedora now has much better handling of dependencies. So now you can have the ability to not say everything's that the package doesn't depend on everything. You can say it prefers to have this thing, and you can install much thinner and smaller. And we're really working to minimize the base image. But as of RHEL 7.2 and all Fedoras now, in the base image is full systemd. So here is the big controversy. What do you run as PID1 inside of your container? So Solomon says you can run anything as PID1 inside of your container. And he says I can prove that because people have run millions and billions of containers with any random crap as PID1 inside of the container. So he's right, except that things break when you don't do PID1 inside a container. So Leonard says that you need to have run a proper init system as PID1. He basically says that the PID1, or the PID1 inside of a system is a protocol that applications in Unix or Linux expect to have happen. So Leonard and Solomon totally disagree on this. Okay? And Red Hat Dan, my internet name, says you should be able to do either. Okay? And that's really my point. Right? Both of these guys are right. Both of these guys are wrong. But there's no reason that we shouldn't be able to do either systemd as PID1 or any other application as PID1. Okay? And so the real goal there was to get systemd to be able to run inside of a container as PID1 in a non-privileged container. I wrote an article that probably a lot of you have read. Sadly, this is the most common way people find out about running systemd inside of a container. And if you look at it, it was written in May 5th, 2014. Okay, so I defined over 2 years ago how to run systemd inside of a container, and no one else has done it since because systemd tends to need to be privileged inside of a container. And of course, you know I don't like privileged. Okay, I like to have things secure. So our goal was always to get systemd to run inside of a container as PID1, but not be privileged. So first I went to the systemd team and I said, let's try to fix this. So why do we want systemd inside of a container? What are the advantages? First of all, it's a proper PID1, so it cleans up zombies. I've had people on our team running Oracle inside of a container as PID1, and they find, after they run it for a half hour or something, they find like 8 billion zombies sitting out there. Okay, so the first PID that they run doesn't know to clean up the other processes. So PID 1 is basically supposed to catch any process that dies underneath it and accept its death into its. Otherwise, you end up with zombies. Another interesting thing that people don't realize right now is any application that you have that writes to devlog, that's a syslog message, those get dropped on the floor if you don't have a proper PID 1. Okay, there's nobody listening. There's no code listening on devlog inside of your container. So the only thing we're logging right now is what the PID 1 of your container is writing to standard out and standard error. That's the only thing that's being logged. So all the messages that are writing to devlog are just disappearing if you don't have a true one. So you really want, a lot of times you want to have journal D support to get syslog messages to the host journal control, but you basically want something like journal D to be running to get you structured logging. And journal D will give you structured logging. So there's a lot of advantages to running that, and there's some disadvantages. I mean, the argument against it is, all I want to run is Apache. Why do I have to run systemd and journal D inside of my container? Why do I need 3 processes when I only need to run, one service? And so there's legitimate arguments against it, but some people would want that. Another real advantage of running systemd inside of a container is you can run apps as designed by the packager. So a lot of people, most people that are building containers right now are using standard RPM packages or standard Debian packages to install into your container. And those packages come pre-configured to run the service in the way that the person who really understands the service would set it up. If you went on and looked at most Docker services, there are all these fancy bash scripts. Really, a lot of them are really crappily written bash scripts. And again, it's almost back to sys5 init, except that these people don't maintain Apache. They're just grabbing some random bash script that figured out how to run Apache, or they're just running HTTPD --foreground as their PID 1. So there's not much thought of what it means to bring up the service in the proper order. But if you use systemd, you can actually do something like this, which is have a Docker file that looks like from RHEL7, install Apache, enable Apache, run your init, done. Apache comes out with proper. So a 3-line service, and you made no programming decisions, right? You basically said, I want to run the init system inside of systemd the way that the guy that maintains systemd for RHEL7, the way the guy manages Apache expects it to be run. So there's lots of advantages to running systemd inside of the unit as PID 1 inside of the container. So why does systemd require privilege inside of a container? Systemd has, when it was designed, basically said /run had to be on a tempfs. It believes that that's part of the protocol. Leonard believes, and his team believes that /run has to be on a tempfs. Inside of Docker files, /run is not on a tempfs by default. All right, so the /run not being on a tempfs, when you run systemd as PID 1, it sees /run is not a tempfs, and the first thing it does is it attempts to mount a tempfs on /run. You need privilege in order to mount anything if you came to my security talk yesterday, so that's instantaneously systemd blows up. The second thing systemd expects, it expects to have sysfs cgroups mounted in, because systemd wants to manage the cgroups inside of a container. Systemd is very happy to have a sysfs cgroups mounted in that's read-only. It doesn't care. It doesn't care if it can't manage it. The only thing it needs is sysfs cgroups /systemd. It wants that read-writable, and that actually can be namespaced. But it doesn't. It wants the rest of them just to be there. And if they're not there, systemd will attempt to mount, and again, we'll get permission denied. So those are the only 2 things that systemd had to happen. And for the last 2 years since I wrote that article, I'm going to now go through all the ways I have failed to get this to happen. So I attempted to patch systemd to work differently in a container. I went to Leonard and said, Leonard, how about if we have a flag that says this is an environmental variable that says container equals Docker, and then in that case, systemd will just use /run instead of mounting the mounting on a tempfs? And he said, no. Then I said, how about we don't require sysfs cgroups if you're running in a container? And he said, no. Then I said, how about another thing that systemd does is systemd, when you kill it, has a very specific signal that has to be sent to it to be killed. It wants sig RTM, RTRM min +3. Everybody remember, there's going to be a quiz at the end of this, what the proper signal is for. So it expects a really weird signal to be sent to it. If you send sigterm to a PID1, it just reloads its config. It does something, I'm not sure that I might be lying in there, but it does something different. It doesn't die. So guess what Docker does when it kills a container? It sends sigterm to PID1. Solomon says you send sigterm to processes that are running to kill them, and Leonard says, no, you don't, that he defined a protocol of what it means to be talking to a PID1, and it's different. They don't agree. So after failing horribly with systemd, I said, maybe I'll get Docker to do something a little different. So I wrote a patch for Docker to just set a container UUID inside of the container, so systemd could figure out what the UUID of the host was and set up its etc machine control ID in it. All it did was a one-line patch that said, take the UUID of the Docker picked and set that to the environmental variable. Docker closed it. I set a patch to systemd as PID1 inside the container, so I added a flag that said init equals systemd, and then have Docker act differently, and mount tempfs and do the cgroups thing, and they closed that one. So then I sent them an implement journal control in the journal data with Docker container 10,094, and they closed that one. And then I sent them have Docker register its machine with machine control on systemd, and they closed that one. And then Jesse Frizzell, who at the time was a systemd maintainer, actually went to DockerCon 1 year ago and had a badge that said, I say no to all systemd specific pull requests. Okay, so I don't think I'm going to get systemd, Docker to care about systemd inside of the container. But I kept on trying. I had some minor successes. So we were able to make Docker stop work. So Docker stop is now a flag that Docker still defaults to sigterm. Docker doesn't like sigterm. So Docker likes, there's a spelling mistake there. Anyways, it's something that looks like that. Systemd requires that for shutdown. Docker run now has the ability to set a flag that says instead of sending sigterm to on kill signal, you can send a different one. That got merged, and we got this merged, which is Dockerfile now has support for the stop signal. So you can say stop signals, there's a space in there, sigterm. I thought I fixed these. Ugh. Okay. So up till now, we got these, that was a minor victory. So we went back and looked at runC. Could we get runC to work properly with systemd as PID1 inside of the container? So runC has this concept of hooks. And what hooks specify commands to execute after the container process gets created, but before it starts executing. So it's kind of cool that you can write an executable that runC will execute just before the container starts running. And it will give you things like what the PID is, what its rootfs is, and what its JSON configuration file is. So we can actually run programs that will set up the environment before the container gets running outside of runC and outside of Docker. So we also had a patch that we tried to get into Docker that basically said, how about if you just look in a specific directory, user libexec OCI Docker hooks, and allow us to just run random executables at the point just before the container starts. So basically, because runC has the support for doing this, and we asked them to do that and add Docker hooks, and that was that pull request, and as you can imagine, it was closed because they kind of knew what we were trying to do. So we said, screw them, we're carrying the patch. So as of Docker 1.10, we're carrying a patch where runC, where we're taking advantage of runC hooks that will basically allow us to set up systemd inside of a unifile the way it expects. So we've added 2 hooks to the system. One of them is called OCI register machine hook. What we're doing with that is every container that runs, everybody, again, systemd has this concept of machine, it's called machine control. And what machine control does is lists all virtualization on the system. So if you run machine control and you have VMs running, it will list out all the VMs that are running on the machine. If you run systemd nspawn containers, it will list out those containers. If you run Rocket containers, it will list those containers out. If you run it with Docker, no containers, because Docker doesn't like systemd. All right, so we added OCI register machine now that basically will register all Docker containers with it, or runC containers, and it's smart enough to know the difference between a Docker container and a runC container. So right now, in the latest Fedoras, if you run containers and run machine control with the OCI register machine installed, you will get machine control do that. Machine control also can do things like starting and stopping containers. And basically, it allows systemd to get into the management of services running on the system, as well as systemd, right, as well as Docker. So running systemd without privilege. So we added another hook called OCI systemd hook that basically will mount a tempfs on run for CD. It will mount a tempfs on /run and on /temp. It also creates a directory via log journals UUID on the host. It mounts via log journal D into the container. It creates an etc machine ID with a container's UUID, and then eventually it mounts all it mounts sysfs cgroup systemd into a container. So those are the steps that happen, and then really cool thing now is systemd will run as PID1 inside of the container and will log its journaling content to the host. So that's why we added these other things about log journal, and the way systemd writes the journal is based on etc machine ID. Now we start to fly a little blind. Excellent. Okay, so if I go into HTTPD here, everybody can see this, I would figure. So I have a Docker file here. And all the Docker file is doing is we're doing a Fedora 23 maintainer. I'm setting an environmental variable. Actually, I don't think you need to do this anymore. And again, all I'm doing is dnf install HTTPD, clean all to make the container smaller, image smaller, enable the service. And I found that there's a couple of DNF crappy services that systemd runs, so I disable those two. I also set the stop signal to be, this is the correct, it's sig runtime minimum +3. I expose port 80, and that's basically the Docker file that runs Apache. So now if I do a instantly done because I did it before, but basically it builds the container, and now I'm going to do a run. And there we have systemd, no errors, without doing any privileged operations or anything. If I go into another window here, and I do machine control, I see the container is running. It's running as a Docker container. If I do a journal control -m of this, see, I should try this beforehand. All right. Well, make pretend that worked. We'll just ignore it now. It usually works. I'm not sure what happened. And if I do a oh, wait a minute. Am I in a container? So there's the SPI. I actually ran I ran, I don't know why I'm running with SE Linux. The SE Linux is on, but it's running as a super privileged container, although it's still running with all the other confinements on it. But basically it's running Apache inside the container, did not mount a file system, did not do anything specific to break out of the container, and runs under a lockdown. And now if I do a Docker stop, you'll see systemd exiting cleanly out of the system. Eventually. Don't you love Murphy's Law? This is why I should record these things. It did exit out. Any questions? I think that's... Any questions? Yes.
First question was, in the beginning you mentioned that with Docker 1.11 the containers can run even though the Docker engine is stopped.
Right.
Does that impact the container in any way? Is there any limited?
So in Docker 1.11, Docker did a major redesign. I don't know why they didn't call it Docker 2.0. In Docker 1.10 and less, when you run a container, you have the Docker client talking to the Docker daemon. The Docker daemon then uses libcontainer to launch a container. So the PID1 inside the container ends up being a child of the Docker daemon. That's why if you kill the Docker daemon, the PID1 goes away. In 1.11, they actually added containerd. So now when I do a Docker run, and they added runC, and they added a thing called containerd shim. So now when I run Docker client, it talks to the Docker daemon. The Docker daemon execs containerd, tells containerd to execute a shell script, execute runC to run the container. So the PID1 now inside of a Docker, the latest Docker is Docker 1.11 and Docker 1.12, is actually 5 executables away from the client. So Docker daemon to Docker client to Docker daemon to containerd, containerd to runC, runC execs the PID1. There's also a program called containerd shim that holds open all sockets that have been handed to the Docker, to the runC PID1. So if I take down containerd in Docker daemon, containerd shim stays open, and when containerd and Dockerd come back up, they will find the container shims and will connect to them, and the Docker stays up and running. Right. So the question there is the Docker daemon used by the client, is the Docker daemon used by the processes? So one of the fundamental things I try to tell people is containers should not be called Docker containers. They shouldn't be called Rocket containers. They shouldn't be called runC containers, open containers, anything. They should be called Linux containers. So all containers are processes that have configurations set on them in the Linux kernel. So they have systemd, they have SE Linux settings, they have cgroup settings, they have namespaces. These are all configurations. All the tooling around them does is configure the kernel to run the process in such a way. Above them, the only thing that the Docker daemon ever did for the processes was to was to know the PID that they're running in and then maybe the cgroup information, but basically hold open the sockets. So standard in, standard error from the PID1 inside the container, and Docker daemon from that point is just transferring that data back and forth to the client. So really the processes inside of the container are all running independent of whatever architecture, whatever tools you use to configure them. So systemd nspawn, right now the systemd nspawn, Rocket, runC, and really Docker doesn't do it anymore because it uses runC. Bubble wrap is one we've introduced. There's all these tools. Again, they're all just management tools that configure the kernel. Okay. And the end of so the question is about libvirt LXC or LXC tools. Those again are just other tools that can be used to set up systemd. To set up LXC, to set up Linux containers. All right, just it's part of the Linux kernel, right? Containers are just a thing in the Linux kernel. Yes. Right. So with Leonard was specific about the two things that we wanted to remove. Okay, Leonard has been working with Leonard works with us. Obviously, actually, he's on my extended team. But Leonard refused to change to /run to not require it to be mounted as a tempfs because he believed that that is an API that the operating system expects. So if I leave cruft on my /run and a service restarts and that cruft causes the service to blow up, then you've broken the. I don't know if API is the correct thing, but there's a way Linux systems are designed and services expect that /run be mounted on tempfs. He also said that you have to have systemd, you have to have sysfs cgroups in there because systemd looks at manages some of the processes it does using cgroups. Is there a way to, so the question is there a way to get systemd light? Everybody thinks systemd is fat, I guess. No, and Leonard would be dead set against, that's systemd container was a version of systemd light. Systemd is not all that heavy. I mean, it's not doing a heck of a lot, so I don't know what a light would mean. I think that there's some antagonism towards systemd because there's a lot of people that think systemd tries to take over the world, and I think a lot of this has, a lot of this antagonism towards systemd is. But my problem is I hate every other tool that people right now are trying to stick into the containers to run like an init system. All right, systemd was designed to manage process. If you're going to run, another thing I want to talk about is a little bit about pet containers. So a lot of people here that haven't dealt with containers right now come into it, and everybody's screaming microservices. So they want to take your big monolithic application and tear it apart, rebuild it as microservices, and then you can deal with containers. The problem is, so everybody goes, well, I'm not going to do that, so they run away. Well, you could potentially run all your services inside a single container and start with sort of a heavyweight type VM type container, and then get used to using containers, and then maybe go back and look at it later and say, I have a web service in there. Maybe I could just pull the web service out. Now I could have 5 services running inside of my container, but I'll microservice just the Apache web server. Now you get that working, maybe you pull out another one and sort of evolve over the process. But you need a nice init system to run. So systemd provides for multi-service containers, and it's the best tool there is for it, and everybody uses it. It's in Ubuntu. It's in all Linux distributions other than, I don't know, maybe Gentoo doesn't support it right now, but all other Linux distributions support it. Yes? Right.
Anyway, regarding the workarounds that are in place now to sort of to make it possible to do this, what scares me is if all the patches are getting rejected, it seems trash. Like someday something's going to break and then we're not going to be able to keep it.
Right. Well, I mean, the argument, Red Hat carries patches for lots of packages that we ship inside of our distribution, and we're basically guaranteeing that we support these things for years on end, right? We patch the Linux kernel, right, with patches that can't get upstream. So we carry those patches. So we're doing that. Now what we're trying to do, we've done a lot of removing patches from the Docker daemon, and we try to get things into lower level tools so they just work automatically. And if the patch is really, really ugly, like the SD notify and the socket activation, we just say the heck with it, we can't do it. But these patches are actually, well, these aren't even patches, they're hooks. So it's actually a separate executable that's running. Now, whether Docker designs something to break our hooks, then we have to react to that. Yes?
What was the size increase that you saw in the base image after the system?
It was tens of megabytes. But I mean, there's this myth that a minimum base unit is really important, except that as soon as you add anything to a base unit, then the thing swells up anyways. So it's sort of like it feels good the first time you pull it down, But what's the difference between a base unit that's shared by 100 containers that's 100 megabytes versus one that's 200 megabytes? So the far bigger things we fixed in the base unit were things like translations. So if everybody would just speak English, we would have had a much smaller base unit, and that's basically what we've done, forced everybody to speak English. Yes? It is. No, Docker does not have full control over runC. runC is part of this. As a matter of fact, Ronald Patel is a maintainer. He works for Red Hat of it. So they have one of the maintainers, Michael Crosby. He's actually the guy that originally created it. But there's multiple people that maintain it. But Docker has, they have the ability to veto it. But I mean, they're a little more reasonable at getting stuff into runC and they just don't like systemd stuff. And actually, we didn't put it, there's nothing systemd specific in runC. It's just runC supports hooks for a different reason, so we're able to take advantage of that. Yes?
I had a additional question. Since you said the only problem with systemd was the MFS and the cgroup sysfs,
Yeah.
did you try to talk with the Docker guys to see if they can make that as unprivileged operation? Because what we're doing is we want to sudo.
Well, it's a privileged operation on the Linux kernel, so the Docker people can't do anything. The only thing we wanted to do was have the Docker daemon do the mounts for us, and that's the things that Docker refuses to put in.
The only reason is because you might be interfering in some other container that's using the same file system at the same physical storage. But because all these are virtual file systems, you can have your own copies of any.
No. I mean, it's easier to do. It's just a matter of getting the config tools to set it up in the right configuration, and that's what Docker refuses. Docker does not like systemd. I mean, it's clear as day that we're never going to get anything to do with systemd to be accepted in the Docker upstream.
The reason I'm asking is because I have my own container that uses cgroups internally within the container, trying to play with different processes that are in.
Right. So if you want to run a container that modifies cgroups by its nature, currently you're going to have to run as a privileged container. Cgroups is being namespaced, so in the Linux kernel in the future, you'll be able to modify cgroups. You'll be able to modify a subsection of the cgroups inside of your container without requiring privilege. Anybody else, any questions? It's all the same people asking the questions. Yes?
Is the Docker engine still needed in runC? I thought that was supposed to
Docker engine Docker engine is not needed to run runC containers. runC is like is the tool for launching the container. Docker daemon is the tool for pulling and pushing images. Docker build, Docker commit, all these other tools are built into the Docker engine. But Docker is slowly being broken apart into multiple different services because there's Docker daemon, containerd. Containerd now is being sort of used for swarming of containers, trying to get containers to scroll up. I would have preferred, if I had a Wayback Machine and I had invented containers, I would have built everything as being standalone little scripts that do one operation really well, sort of like core utilities, right, and break them apart instead of building this big monolithic daemon. But I mean, that's what we got, and it's slowly moving away. We're building tools, but Docker's a tremendous tool. I don't want to. There's a huge by the way, if you want to go find out more about this talk, someone wrote up the talk on LWN, and Docker reacted very badly to this talk. So you can go read. I don't respond to those things, but LWN has a huge chain. So look for Docker versus systemd in LWN, and you can read lots and lots of comments and people fighting back and forth about whether systemd is important or not. So you can get lots more information, including Solomon's in there. Anything else? Okay, thanks for coming.